skin cells, you were taking them back to stem cells, then you were provoking that stem cell to either become heart or lung or liver or something, so that if you got skin cells from somebody, you could make them.
That is only with the heart, unfortunately. We haven't learned how to make the most functional liver cells out of stem cells yet. That is definitely a hot field. It is a big field because can you imagine how amazing that would be if we could take a skin cell and then regenerate our liver. We have colleagues at Wake Forest who are doing some interesting things where they're taking stem cells out of our own grown-up kidneys. They're expanding them in the lab and they're putting them back in clinical trials and regaining some kidney function. This is, I think, a phase 2 clinical trial now. So there's a lot of hope, I think, in the field of regenerative medicine. What we're doing at Los Alamos is not necessarily regenerative medicine, but some of the things we learn may help inform people who do regenerative medicine. Yes, sir.
Yeah, you were talking about how even bone is, much softer than these substrates that traditionally have been used. Is there a reason that you can't, for instance, use bones as a substrate, just get some bones, just like you harvest other cells? Maybe there's somebody who's got an organ donor who has maybe some extra bones that you could use, and just kind of do your experiments right on those bones, and you can maybe even make modifications to them. Is there a reason that you can't do that as opposed to some of these more complicated things you're doing to try and imitate the properties of?
And that's not necessarily a bad idea at all. That's actually quite a good idea. One of our team members who's not here tonight is working on the neuromuscular junction. And so from our spinal cord to our muscle, we have a peripheral nerve, and then that peripheral nerve goes into our muscle and tells it to move. And she's trying to create this in a laboratory environment. And one of the problems she has, she's also trying to create it on, she's been looking at polyurethane, she's been looking at glass, other substrates, to try and provide something for this muscle to attach to that won't rip the muscle off of the bottom, because the muscles jump. And when the muscles jump, if they're attached to something, they tear. And they damage themselves. And so that's not a bad idea to think about, could it be attached to bone? Could we use a lever? That kind of thing. I think that's a great idea.
You got it.
Yes, sir.
I thought there was some legal/political issues regarding using stem cells. Has that gone away?
There were, and it's actually interesting, without going too deep into the political story, there was a time in our nation where fetal stem cell use was not allowed to be done using federal funds. And all of us pretty much are federally funded. National Institutes of Health funds a lot of things, Department of Defense funds a lot of things. And at that time, scientists thought, oh no, we can't use fetal stem cells. What are we going to do? Because those are the only stem cells we got. Well, actually that changed the whole paradigm. Scientists started looking for other places to get stem cells. We knew that in our bone marrow, we have stem cells that make blood cells. We have been using lung stem cells that are found in the branches of our lung to turn into these alveolar cells. And scientists took these heart cells that, I can't say that we did not do the turning of the heart cells into all of these things. Scientists elsewhere took these skin cells and turned them into heart cells. And we buy them. And so the new paradigm is that we have stem cells all over our body. We have even stem cells in our brain and our neurons. They're just not very many and they're hard to find. And now, 20 years ago, we said there was no such thing as stem cells in a grown-up, but now we know differently. And I think that's actually going to change the field of regenerative medicine, and that 20 years from now, someone will be able to make us a new kidney or heart or pancreas. Pancreas would be great.
So it's kind of like prohibition. People will always find a way around the rules.
Well, and the rule was no fetal stem cell use, but they didn't say no grown-up stem cell use. And as a grown-up, I can say, I allow you to do this. And I think a lot of this, and yes, it can be distasteful to say, this fetus didn't choose to do this. But I, as a grown-up, can choose to give you some of my skin, and you can make a new heart out of it. I think that now it is actually legal, I think, to do fetal stem cell research, but rarely is it done because now we know we can use grown-up stem cells and grown-ups can give consent.
Can't you do fetal stem cell research from umbilical cords?
There are some from umbilical cords, and I don't know whether those are considered fetal or not, because that's sort of a
Yeah.
in-between thing.
Yeah.
But I think finding stem cells in less distasteful places was something really, really good that came out of, I don't want to go into any political discussions, but I think finding stem cells in places that were not distasteful, like from adults, is a good thing that came out of all of this.
PJ's got a question.
Yes, PJ?
Just wanted to add that there are two therapies which are coming out this year, one in Europe and one in America, which is going to use stem cells, and they should be approved. So we should actually see stem cells being used in the cures.
What kind of stem cells was
So
that?
they actually are the iPS stem cells.
Oh,
Yeah,
perfect.
so
So
that
those
one-
are the ones that came from grown-ups.
Right.
Yeah. That's fantastic.
What would the DOD like you to deliver if you could tomorrow to them?
Gosh, if we could give them something tomorrow.
Yeah, what, I mean, they're funding this,
Yes.
for an endpoint, for real need. What are they hoping that you'll beat the clock on?
If we could give them their ultimate wish tomorrow, I think their ultimate wish would be that our organs all hooked together behave exactly the same way as a human, and that we can test the drugs that they, or pharmaceuticals that they would like to use to save our soldiers for efficacy and toxicology, because we want to make sure the drugs work and we want to make sure that they don't hurt anybody. But to have the organs function all together exactly the same as they do in a human, and to be able to say, yes, this is going to work, no, this isn't going to work.
It's to thwart a bioweapon, basically.
To thwart, yes. Because if the DoD has actually funded lots of studies. We're not involved in the pharmaceutical design, but the DoD has actually funded lots of pharmaceutical research to develop countermeasures against sarin, which some of our soldiers are exposed to, things like that. And we want to know, are these countermeasures going to work before we give a pharmaceutical to a soldier? Yes, sir.
Maybe eventually you can write a book under the pseudonym Mary Shelley.
Well, so one of our, we're not allowed to have slides here in the bar because it's supposed to be an engaging conversation, and this is great. But one of our